Hey guys, welcome back. We were dealing with isomerism, and I have just given you an idea that isomerism is a process in which we are going to deal with isomers, and the only isomer types which we are going to discuss with you at this stage will be structural isomer. Okay, so examiner can ask you write down the structural isomers of this compound. For example, this can be one type of the question. Okay. So right now I have just written this on this page that whensoever the compound is quite very simple, I mean to say having very lesser number of carbon atoms, it means that its chain is quite very shorter. Hence, in this way, there is lesser possibility to make rearrangements. Okay, but when we are talking about a compound having longer carbon atom chains, it is very, very possible to make different rearrangements, to make different structural formulas. In this way, we can say that we can make different structural isomers. Okay. We are going to practice this. For example, I am writing a compound here, and this compound is of 5 carbon atoms. Okay. In this 5 carbon atoms, guys, I'm not writing hydrogen atoms. Already you know this thing that how many hydrogen atoms each of the carbon atom will have. Many of the students will ask me to make a practice for this as well. I will do the practice, don't worry, but right now I'm just telling you what type of the rearrangements are possible in this case. Okay, just look at here. So this is 5 carbon atom, this is also 5 carbon atom, but it has 1 carbon atom as a branch on position number 2. What is the meaning of position number 2? For example, if I am counting from this side, this is carbon number 1, this is carbon number 2, this is carbon number 3, and this is carbon number 4. At position number 2, there is a 1 carbon atom branch. Okay, what is a branch? How we are going to count the position number, etc. All these things will be discussed with you in detail when I will teach you the topic of naming. Okay, right now I am telling you that there is one more possibility to make another rearrangement, and that is this. Here you can see this thing that there are 2 carbon atoms which are not part of the direct counting, rather, they are part of the branches, you may say. Okay, so one of the branches at the top, whereas the other branch is at the bottom. Whereas we can say this thing that 3 carbon atoms are making the main chain. So this is how we can say, this is the way we can say that carbon atoms are rearranged in this case. Okay, now I am on the next page, and I am going to tell you that how we are going to have naming for these compounds. Guys, before moving towards this topic, I'm going to explain you that as naming and isomerism are working closely to each other, if a student does not know about naming of a compound, he will not be able to understand, or she will not be able to understand the isomers as well. Okay, so it is highly advised to write down the name first so that you people may be able to get the isomerism more perfectly. Okay, guys, so for naming of alkanes, for naming of hydrocarbons, you may say for naming. Okay, so for naming, following are the rules. For naming, following rules will be there. Okay, so now what rules will be there right now? Let me inform you. Number one, select the longest carbon atom chain. Select the longest carbon atom chain. Select the longest carbon atom chain. Okay, now number two is select that side in which the branches are at smaller number. Okay, so give branches, give smaller number to branches, smaller number to branches. Okay, I will give you the example, so don't worry about that. Number three, there should be a dash between an alphabet and a number. Okay, alphabet dash between alphabet and a number. Okay, and there should be a comma between numbers. Okay, between numbers, between digits, there will be a comma. Okay, so guys, there can be other rules as well. For example, bromo should be first before chloro. It means that whenever any compound will have bromine and chlorine, you are going to call them as chloro and bromo, but B comes first in the alphabetical order. So B will first, so bromo will first, and chloro will be second, etc. Don't worry, I'm going to make the practice for that. You can see this. Okay. Just look at here right now. It is 1, 2, 3, 4, 5. Okay. How many carbon atoms are there? There are 5 carbon atoms. And is there any carbon-carbon double bond? No, there is no carbon-carbon double bond. So what it is? It is a 5 carbon atom chain having carbon-carbon single covalent bonds only. So what will be the name of this compound? It will be called as N-pentane. Okay. Why N-pentane? Let's see. Okay. First of all, you are going to write down the hydrogen atoms as well. I was not writing the hydrogen atoms so that I may be able to do as many as possible in one video. But I'm writing this thing here in the first one. You can see this thing that it is going to make two more bonds, three more bonds, because it is making one. So it is going to make three more. It is going to make two more. It is going to make two more. It is going to make two more. It is going to make three more. So this is how we are going to make the numbering. This is how we are going to make the hydrogen atoms over here. Okay. So it is H3, it is H2, it is H2, it is H2, and it is H3. This is how we are going to write down the numbers for this hydrogen atoms. Now, why it is called as N-pentane? As there is no branch, so that's why it is called N. Whenever there is a straight carbon atom chain, we are calling it N. Whenever there is nothing else is part of that compound, we are calling it N. So this N thingy is just a representative of this. What about this pent? Pent is just telling you that there are 5 carbon atoms. That's why this is pent. Pent stands for 5. And ane stands for carbon-carbon single covalent bond. Okay, so that's why it is called as N-pentane. Okay, what about this now? Look at here right now. I am just writing the four carbon atoms like this, whereas one carbon atom like this. Now what will be the name? I have just told you that you need to give the longest carbon atom chain. Select the longest carbon atom chain with the smallest number to the branch. Okay, if I'm start counting from this carbon, it is 1, it is 2, it is 3, and it is 4, and there is a branch at position number 3. Okay, if I'm going to start counting from the other way around, I'm writing with another color. So it is 1, it is 2, it is 3, and it is 4. I can say this thing that the same branch is at position number 2, whereas according to the first counting, the same branch was at position number 3. So we are going to select that method, that way, that counting, in which we are going to give the smaller number to the branch. So it is at position number 2, and that is called a branch of one carbon atom. Guys, before moving ahead, I would like to bring your attention to the next point, and that is this. What is this right now? For example, let me inform you that there is one thing which is called as alkyl radical. Alkyl, you may consider alkyl. What is an alkyl? So whenever an alkane is there, and if we are going to minus one hydrogen out of the formula, it is giving you the respective alkyl. It is giving you the respective alkyl. For example, the first one is methane. The first member is methane. When we are going to remove one hydrogen out of it, it is going to give you what? Methyl. It is going to give you what? Methyl. And in case of ethane, it is going to give you ethyl. Ethane minus one hydrogen is giving you ethyl. Okay, it is going to give you ethyl, and then it is called propane. And when we are going to remove one hydrogen from propane, it is going to give you propyl. Okay, let's see the formulas now. Okay, I will write down the formulas along with them, but I'm going to write them with the red color so that you people may be able to differentiate. So it is CH4, for example, the formula of methane. When we are going to subtract one hydrogen out of it, it is going to give you what? CH3. So here it is C2H6, and when we are going to remove one hydrogen, it is going to give you C2H5 called ethyl. Here it is C3H8 called propane, and the propyl will be C3H7. So this is the way. These are the examples of alkyls, and these are the examples of one carbon atom branch, two carbon atom branch. Guys, remember this thing that alkyls can be the type of the branches. Alkyl can be the type of the carbon atom branches along with the different types of the organic compounds. Let's go back to this example. Here we can see this thing that there is one carbon atom branch at position number 2. So it means that we are going to neglect this. What will be the name of this now? one carbon atom branch is called as what? That is called as methyl. So we will call it 2-methyl. The compound name will be 2-methyl. I have just told you that there will be a dash between an alphabet and a number. So 2-methyl. What is the meaning of 2? At position number 2, there is one carbon atom branch. Okay. So 2-methyl, 2-methyl. And how many total carbon atom chain? The length, the basic length is of 4 carbon atom. So it will be butane, 2-methyl, 2-methyl butane will be the name of this compound. So it is just telling you, I am repeating my words, at position number 2, there is one carbon atom branch. So that's why it is called as 2-methyl. That one carbon atom branch is called as methyl, and that is called butane. Why it is called butane? 4 carbon atom chain is called as butane. I am going to change the board so that there can be more ideas about this, and that is this right now. Okay, you can check this thing. For example, this is here. Okay, and there are 2 carbon atoms as a branches you may consider. Let's count this thing. For example, if I'm saying 1 2 3 4, okay, if I'm saying 1 2 3, no, we have to select the longer way. Okay, so if I'm saying 1 2 3 4, okay, if I'm saying 1 2 3 4, okay, if I'm saying 1 2 3 4, so it means that there is only one option which is giving us 3 carbon atom chain. Rest of all are giving equal 4 carbon atom chain. So we can select any of the way. 1 2 3 4 can be the correct one. Okay. 1 2 3 4 can be the correct one. Okay. 1 2 3 4 can be correct one. Okay. Okay. So there can be any other possibility through which we can make a 4 carbon atom chain. Now let's see what we are going to write now. It is carbon number 1, it is carbon number 2, it is carbon number 3, and it is carbon number 4. At position number 2, there is a branch. At position number 3, there is a branch. Okay. So what will be the name of this compound? That at position number 2, there is one carbon atom branch. At position number 3, there is one carbon atom branch, and the total carbon atoms are 4, which are making the main chain. Okay, so what will be the name of this compound? It will be 2 comma 3 dash dimethyl, 2 comma 3 dash dimethyl butane. Okay, it is just telling you that at position number 2 there is one carbon atom branch. At position number 3 there is another carbon atom branch which is also one carbon atom, and the total number of carbon atoms are 4. So it will be 2 comma 3 dash dimethyl butane. This compound will be this name. Why it is so? Butane means 4 carbon atom chain. Ane means that there is no carbon carbon double bond. All of the carbon atoms are attached with each other through carbon carbon single covalent bonds. So this is the way, this is how we can give the name to the organic compound like this. Is naming finished? No, 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 no. Okay, make it clear that we are going to make lots of practice so that we may come back towards the isomerism. You people may be able to get that concept better. Okay, let's have another example. Okay, so this is this, and this 5 carbon atoms. Okay, and one branch is here and the other branch is here as well. Okay, so it means, oh, we can see this thing that one branch is at position number 2 and the other branch is also at position number 2. So this is the point to be noted, that both of the branches are on the same carbon atom. Is this possible? Yes, this is possible. That's why I'm giving you. Okay, so what will be the name? 1, 2, 3, 4, 5. I am not counting from the other way because it is just this way in which I have written is just letting me know that at position number 2, it is giving a smaller number to the branch. So that's why at position number 2, there is one carbon atom branch. At position number 2, there is another. So what will be the name? It will be 2 comma 2 dash dimethyl pentane, dash dimethyl pentane. It is just telling me that one branch is at the same carbon atom and the other branch is also at the same carbon atom. That's why I'm writing 2 comma 2 dash dimethyl pentane. We are going to continue this topic in the coming lectures as well. All the best to all of you. See you in the next class, inshallah.